Hello, everyone. My name's Callum. I'm joined here by Leo Lee, and we're both software engineers at Red Hat. And today we're going to be talking about how you can cut the complexity of providing tools to agents and do that by building MCP servers really quickly with GenMCP. To help show how this all works, what we want to do is walk you through a scenario of when you might want to use a technology like GenMCP. And for that, Leo's going to start by giving us our scenario.
Yep. Thanks, Callum. I'm an owner of an e-commerce website that sells a lot of products, and I built this website, and it's used REST API as endpoint, and it's being hosted on OpenShift. Let's take a look at the website first. This is a little website that I built to sell my products. As you can see here on the left side, there are some product selection, and users will be able to click on Add to Cart to add their favorite item into their cart. And in the middle, you will see all the content in the cart. And on the right side, we have our little chat agent that will help to better provide your shopping experience. For now, it doesn't have any access to the tools. For example, like get the products or add item to the cart. For example, here, if we try to ask the agent what product are there in the website, it will not be able to retrieve the information and answer you. And as we can see here, it's connected to OpenAI, and as you can see in the response, they cannot retrieve the information. As you can see on the right side, there's a little chatbot area that is my personal shopping agent for my customers, and I'm considering to add the LLM-powered personal shopper feature, which allows it to help my customers search the products, add the product to their carts, and clean their cart, etc. I have tried a lot of techniques, try to build this agent for my customers. I think about this to convert my REST API code into the callable tools in the specific SDK for my agents, but I think it's not portable, and I need to maintain a lot of code base. And I also checked online a lot of guides to build MCP servers, but it seems like more complicated than I thought, and it's really hard to maintain and build. So what do I want? I want a way that is fast, easy, and reliable and maintainable to build tools for my agents in my websites. And as I mentioned before, my website is hosted on OpenShift. I want it to be scalable. And some of my tools in the websites, I wanted them to be easily switchable. And for example, some of the important endpoint, I don't want an agent to be accessing, or some of the tools I wanted to prohibit them from using. I need to have the option to do that. So Callum, are there any options that I can do that fast, easy, and reliable?
Yes, Leo, there are. This is where the project GenMCP comes in. GenMCP is aiming to solve all those challenges around integrating existing systems into agentic applications. And it tries to do this by giving you this straightforward way to map any kind of API or CLI or just existing code into tools or resources that your agent can call. This lets you automatically create MCP servers around your existing systems, so you can integrate agentic AI into your existing workflows. It gives users control over which data and endpoints should be exposed. And it also allows for iteration on tool definitions, so you can improve the performance of those tools over time and understand that this is actually improving or not. So let's try it out. I know for this website Leo built, there's an open API spec, so we can use GenMCP to quickly convert that into an MCP server that we can run. Great, so we have this e-commerce application, and it has a REST API for all the backend. And what we want to be able to do is create an MCP server to some of those endpoints, so that our agent is able to, interact with those endpoints and make purchases for us, and any other agent is able to interact with our site as well and make purchases as long as it has the correct credentials. So to start, we're in this empty MCP directory. And running locally, we have the backend, which includes the OpenAPI spec. If we curl that, we can see we get out some big, long OpenAPI spec. And what we want to be able to do is turn that into something that GenMCP can work with. So to do that, we're going to run GenMCP convert, and then the URL. Now this could have been the file path to the OpenAPI file locally as well, but in our case it's URL, and GenMCP works perfectly fine with that. So we can see it fetched the OpenAPI spec, converted those 9 endpoints to MCP tools, and created an MCP file and an MCP server.yaml.
A quick question. If my website doesn't have the OpenAPI.json, what should I do?
Well, because it's just creating these YAML files for me, if you don't have something like an OpenAPI.json, you're always welcome to write those files yourself. This is really just a convenience to make it really fast for you to get started with GenMCP.
I see. That makes sense. And I saw on the terminal there are 2 files being generated. Can you tell me a little bit more about that?
All right, so that's a good question about what's in the MCP file. So let's think more specifically about what's in these different parts of the spec. So first of all, we have this file called mcpfile.yaml, or you can rename it whatever else you want. And this is going to contain all the MCP specific definitions. So for example, which tools are available, which resources, which prompts. These are all different concepts in the Model Context Protocol spec. And essentially tools are things that agents can call, resources are things they can ask about and get the contents of, and prompts are specific prompts on how the agent should interact with the MCP server. And so the MCP file contains definitions that let you declaratively describe all of these things. Specifically, how should the tool be presented to the MCP client, which is normally going to be your agent. This will map one-to-one to the MCP specification for how these are described, giving you full control over everything you'd expect to be able to tell the agent about these tools and resources and prompts. Then there's information on how GenMCP should call or execute the tool or resource or prompt. And this is going to be things like which URL we should call, which method, which headers. And so in this way, GenMCP is basically taking the JSON specification of the protocol and then adding some extra information so that we can turn this into a working server.
So I don't need to write any codes to maintain it, right?
No, you just maintain these YAML definitions. And then the idea is you're already maintaining a whole system, maybe your REST API or whatever else. So you shouldn't need to maintain this wrapper layer. You just need to tell GenMCP what's there and how to present it to the client.
And all by natural languages.
Well, it's a YAML file with natural language descriptions is mostly how tools are presented to LLMs. Granted, the URL and which headers to apply, that's not so much natural language, it's just what the URL is, but the MCP parts will all be natural language. The second file we have is the server configuration. So whenever we're running something, we actually want to be able to configure the server and maybe change things between staging and production or just a local dev loop. And this includes configurations such as server level instructions. This is a kind of server scale instruction you can give to MCP clients. Configuring logging and authentication and TLS, features like that. Great, so now that we know that we have these MCP files, and this mcpfile.yaml, mcpserver.yaml, what we want to do is run these. To do that, it's really simple. I can just type genmcp run in the terminal, and it's going to start an MCP server for me. And it's starting on port 8080, that's again coming from that mcpserver.yaml configuration. So now let's go over to our site, which we're going to configure to work with this MCP server and see what's happening. All right, so now that we have a running MCP server, we've actually connected it into our e-commerce site, and we can see now that the agent has tools online. So that means I should be able to ask prompts to the agent, and it should be able to interact with the back end of the site and answer them. So for example, I can go back to our prompt from before and ask what products are available, and it's going to think, and it should use a tool to actually get the products, and then summarize the answer from that. So it's able to get the products available in the store, the ones directly from over here, and tell us about them over right in the chat. Right away.
Wow, that's such an easy and fast process to set up the tools for my agent. I'm wondering, are there any ways to test whether my agent is using the correct tools? I don't want to write 1,000 of prompts to manually test that out.
So that's a good question you had, Leo, about how to know how good a server is. And crucially, it's a complicated question to answer because we don't want to necessarily look at just evaluating how good the chat agent is itself. That's a common challenge with MCP servers because ultimately we're giving these natural language descriptions for LLMs to be able to interact with our tools in the agent loop. But what we're able to look at is the agent and what was the outcome of the agent, right? And so when I'm making the MCP server, what I care about is how well the agent's able to use my tools in specific scenarios, and that's what I need to be able to test. And so just testing the agent as a whole isn't necessarily telling me how good my MCP server is, it's telling me how good my agent is, which are not the same question. And this is where this new project we've been working on called GEvals comes into the picture. GEvals helps us to answer questions around how good an MCP server is. This lets us do things like understand how well different models or agents can use an MCP server. Lets you understand if the changes you're making to your MCP tools or resources are actually improving performance or not. But also, if you're capturing scenarios where your agents are currently failing to complete tasks correctly and integrate with your systems, using these as evaluation scenarios will let you measure whether they are able to improve or not over time as you make changes. So for example, a lot of chat interfaces have a thumbs down button. If you capture all those as these are the scenarios where things don't work, you can quickly turn those into eval scenarios and start testing whether or not you're able to fix this integration problem. So how does GEvals actually solve this problem? It solves this by creating an MCP proxy server in the middle that lets us track every MCP interaction and actually make assertions on those MCP interactions. So that way, when we run an agent on a set of tasks, we're able to actually develop a deep understanding of how the agent is using whatever combination of MCP servers we want to accomplish those tasks, letting us change things about our MCP servers and understand how well they're performing in the context of agents as a whole. So, how do I use this so I can understand how well my MCP server works? First of all, we're going to need to create some GEvals resources, in particular, the eval tasks. These are going to be describing maybe some environment setup, and then a prompt, and then a way of verifying that the agent did the right thing. And then maybe you need to clean up the environment as well. Then there's the agent configuration. The agent configuration is basically telling GEvals, hey, here's the agent I want to use, and here's how to connect that agent to some set of MCP servers. Because again, GEvals is creating an MCP proxy server, so it needs to configure the agent at runtime with the MCP servers it's using. And then there's the overall evaluation scenario. This is going to tie together the specific tasks you want to run, which agent you want to use, which MCP servers you want to be evaluating, and then you can add some specific MCP server level assertions around all those different interactions. For example, are specific tools being called? Are specific tools not being called? Are my tools being called too many times? So there's kind of these ideas of efficiency. And when you put that all together into this overall evaluation scenario, then you're able to run it and see how good your server performs. So let's evaluate this MCP server we've been building throughout our demo. All right, great. So now we have our running MCP server over here. This is the same MCP server we've been working with so far, and what we want to be able to do is use GEvals to actually evaluate that. So over here, in the eval folder of our demo repo, I've created some evaluation manifests that go with that GEvals setup from before. So for example, we have this eval.yaml, and in there we're saying, hey, this thing's an eval. It's configured with this built-in OpenAI agent, specifically using the Qwen 3 8 billion model, since that one it helps our demo in a bit. And then there's an LLM judge, and then there's these task sets. So we're saying, hey, run all of the tasks in the tasks folder, and we're just gonna do some really simple MCP assertions for now. We're just gonna make sure it's actually calling our e-commerce MCP server. It's using at least one tool, and at most 10 tools.
I saw there's a word called LLM judge, what it is, and what is the difference between that and agent?
Yeah, that's a great question. So a very common thing that occurs when you're testing agentic applications is you get some kind of text back from the LLM, specifically when you're asking it a question where it's supposed to summarize some information for you. So what the LLM judge does is it judges if the output was correct or not. And that's a lot more robust than just doing some kind of string match, because the LLM might just swap the order of a couple words in the response, but still be semantically correct, which is what we're really looking for with the LLM judge. There are more advanced use cases of LLM judges, for example, looking at the tone of the response. But for the purposes of testing an MCP server, what we care about was, did it have the right information? And that's what our LLM judge is doing.
I see.
So continuing on, we have a couple tasks in that tasks folder, which we're going to run. We've got an abandoned cart scenario, an add items to cart scenario, and a summarize cart contents. As an example of one of those which has that summarize cart contents and that LLM judge, we can open up one of these files. So now we have this file open up, and we can see that the way the task works is there's some setup steps, and then a prompt, and then some way to verify, and then some cleanup. So for our setup, we're going to add some items to the cart, and then we're going to ask what is in my cart. And with the LLM judge, we're going to verify that the answer contains mechanical keyboard and multi-tool device. And then for cleanup, we actually have this demo reset URL, which we just call to set everything up to be nice and clean for the next run. Great. So now that we have looked at this eval file and all of these tasks, let's run the eval scenarios. When we do that with GEvals, we'll say GEvals eval, and then that eval.yaml file, and it's going to start running all these evaluation scenarios. Now these can take a couple minutes, especially since we're running them with a local model today. So we'll fast forward through until these have finished.
Wow, that was easy and fast. So I can just define the task in the file, just like how I do in the integration test, and run it. So I don't need to manually testing and do the prompting over and over again.
Yeah, exactly. And what's great here is actually, not only do we know which scenarios it's passing and which scenarios it's failing, it's going to tell us exactly what happened through this JSON file. And we're looking to make it better to work with than just saving everything to a JSON file, but there's a lot of really valuable information in this JSON file, which lets us move from having one or more of our tasks failed to having them all passing. So it tells us where it saved it, and we can go and take a look at that. If we open up that GEvals out.json, we can see the different scenarios, and we're specifically looking at the add items to cart scenario. So we can see the output. So the graphics card has been successfully added to your cart. Since the API only allows adding one item per request, you'll need to add it twice more to reach total free. Would you like me to proceed with adding the remaining items? So it seemed to not quite pick up on the fact that it should just keep calling this more times. and one confirmation. And if we look through the tool calls, we can see what the model was actually doing throughout this interaction. So it started with a post to that like add an item, and it got an error saying product not found. And if we look here, it's because it passed in this argument product graphics card. And this is part of a thing that happens in a lot of real world APIs. They're not amazingly formulated or described. In our case, product is actually supposed to be the ID of the product, not the name. So next, what our agent does, we can see, is it called the get product. So it wants to see, hey, what products are there, right? And it actually got back these products and it was able to figure out that, hey, it should use the ID, right? And so it calls it again now with the ID, and it was able to add it once. But at that point, it was a little confused, wanted to get some confirmation, and it stopped. So if we want to improve this, we don't actually need to deeply change our MCP server. We just need to improve the descriptions of this API. So let's do that. Let's hop over to our other terminal window and change that MCP file.yaml. Great, so now we're in this MCP file.yaml and we want to be able to change our descriptions of our post tool. So we can go to that post API card items. These are all auto-generated names. And one way you can improve the performance is just improve the names. For now, we're actually going to just focus on the description of the properties in the tool itself, and that should be enough for our use case. So instead of just saying, hey, this is a product ad, we can say the ID of the product ad. We can say call get API, is it products, Leo?
Mm-hmm. Yes.
Call get API products to find the ID. And we also say call this tool multiple times to add the correct number of items to the user cart. So in this way, we can really quickly start fixing those problems we're seeing with how the LLM understands our tools. So if we were to rerun this, it should hopefully do that. And then I can just rerun my MCP server. We're running again, we're all happy. And hop back over here, and we're going to rerun our evals, and hopefully we're going to see these tasks starting to pass now. So I can say GEvals, eval again, and that same eval.yaml. And once again, these are going to take a minute or two, so we're going to fast forward until they worked. Great. So as we can see, it's finished running, and actually now, all three of our tasks passed. And again, it saved everything to the output file in case we want to take a look at how they passed, but all of our tasks passed. And so the task status passed, meaning that that verification of seeing did do the right thing passed. And the assertions, those are those MCP level assertions where we're checking, hey, did it actually use our e-commerce MCP server? And did it use not too many tools, and did it use at least one tool? And so in this way, if you had more complex assertions about your MCP server, you'd be able to say, well, the agent did the right thing, but maybe it didn't actually use my MCP server correctly to do that, which is another concern for MCP server authors.
Kellen, you know what? One thing I really like about it is you can find actually all the error logs, all the requests and response in the error logs. That really helps me when debugging, and I don't need to go to go to the tab and see the response and see where it goes wrong. It's everything just in one file. That's so convenient.
Yeah, it makes it easy, and it makes it easy for us to figure out what went wrong and then fix it, so that really quickly, in just a couple minutes, we went from not having an MCP server at all to now we've evaluated it. We saw some problems, as easy as editing an MCP file, just YAML for a few minutes, and run it again, and we're passing all of our evaluations. So that's part of the power of evals. Great, so now that we've evaluated our server, everything's working, we're all happy. What we want to do is burn this in production, since we know that this is actually working correctly and it's working well in our scenarios. So GenMCP has support for that, and I can use the GenMCP build command. I need to do this back in that MCP directory, and I can say GenMCP build, and then I've got to give it a tag. I'm going to use my personal Quay account, and we'll say GenMCP GEvals e-commerce demo, and then I'm actually going to want to push this to Quay. And so now you can see it's building that multi-arch image that we're talking about, and it's pushing the image index over to Quay. Give it a couple seconds. Great, so now we can see we have in Quay our new image just pushed now, tags latest. This was just pushed a couple, 1 minute ago, 3:45, 3:45. And we can see in here we've got Linux on AMD 64 and Linux on ARM 64, so it's a multi-arch image as well. And now I can take this to OpenShift or wherever else I want to run my MCP server and use this in production, since we know it works well from our evals. Thank you for taking the time to learn more about GenMCP and GEvals. If you're interested in the project, please check out the project website. If you have any questions, leave comments here or message me on any platforms where I'm available. Thank you.
Thank you.